Hi, good evening, everyone. Today, we are going to go ahead and we are going to talk about general equilibrium. Okay. Now, first of all, what is general equilibrium? General equilibrium is where we are talking about simultaneous equilibrium in many markets. Okay. Now, this can take the form of two consumer, two good, two producer. Generally, huh? माने when we begin talking about general equilibrium, सबसे easy case जो हम देखते हैं वो होता है two consumer, two producer and two good. So it's also called as two cross two cross two economy. Majorly जब हम एग्जाम्स की बात करते हैं so we will notice that in exam majorly the questions will come from this part. इधर से ज्यादा क्वेश्चंस आएंगे, right? The producer side of general equilibrium is not very often asked, but जो हमारा consumer side of general equilibrium है, that is something which is going to be asked more in the exam. ठीक है? So this is the main definition of general equilibrium कि क्या general equilibrium है क्या, where we simultaneously go ahead and we find the equilibrium condition of all markets together. This was developed by Walras, and that is why it is also called as Walrasian equilibrium. And all markets here are independent of each other. माने अगर एक market में कुछ भी change आएगा, suppose if we change the total amount of good available, good X available या good Y available, or if we change the price of good X, price of good Y, it will go ahead and it will change the demand also. ठीक है? And price कब change होगा? Usually if cost of production will change, then price will change. So for example, अगर मैं एक perfect competition की बात करूं, if I talk about perfect competition, that firms are in perfect competition, so I know P is equal to MC, price equal to marginal cost. अब अगर due to some reason, let's say that there is increase in raw material cost, माने cost of production बढ़ रहा है, right? So increase in cost automatically means my marginal cost will increase. अब अगर marginal cost increase होगा, so it will mean that my price will increase. So we can go ahead and say that there is going to be increase in price of the commodity. ठीक है? अब हमें पता है that the equilibrium condition for any consumer is where MRS is equal to PX by PY. ठीक है? तो if the price in any good will increase, suppose good X का price increase होगा, it will change the consumption of good X. हमने पूरा डिटेल में पढ़ा है, substitution effect, income effect and so on and so forth. So it means कि this is a complete interdependence. One thing is dependent on the other. एक चीज का दूसरी चीज के साथ complete interdependence है. And that is what exactly we have gone ahead and we have written here, that there is an interdependence. चीजें एक दूसरे के साथ dependent है. So generally individual consumer and producer equilibrium निकालना, we have seen how to find consumer and producer equilibrium generally. But now what we want to do is we want to find Walrasian equilibrium. माने we want to find out simultaneous equilibrium. और simultaneous equilibrium के लिए there are two kind of markets which we must study. जो पहला market होता है, that is called as commodity market, right? So in commodity market we require that the demand of the commodity should be equal to the supply of the commodity. Demand and supply should be equal to each other. और ये supply commodity का कहां से आएगा? Well, when we talk about two consumer, two good case, right? With though what I said ki will come most probably in your exam. So जब हम two consumer, two good case का बात करते हैं, when we assume that there is no special producer, कोई अलग से production की बात नहीं कर रहे हैं, then we assume that these consumers they go ahead and they have something which is known as an endowment bundle. इनके पास कुछ endowment bundle है. What is an endowment bundle? Endowment bundle is any bundle which they enter the market with. Right? So we assume कि ये जो भी हमारे consumers हैं, they are entering the market with certain amount of good X and good Y. And वो जो होगा, it will be called as the endowment bundle. उसी को हम endowment bundle बोलेंगे. And that will be the starting point of the entire general equilibrium. तो यहाँ पर when we say demand equal to supply, this supply is nothing but the endowment bundle of the consumers. If there is no production taking place in the economy, the endowment bundle becomes the supply bundle. Endowment bundle becomes the supply bundle. इसी तरीके से there can be equilibrium in the factor market also. तो there may be different factors of production जैसे labor, capital, land. एंड इक्विलिब्रियम रिक्वायर्स कि ये जो भी मार्केट का हम बात कर रहे हैं सेपरेटली ईच ऑफ देम शुड बी इन इक्विलिब्रियम. सो डिमांड ऑफ लेबर शुड बी इक्वल टू सप्लाई ऑफ लेबर, डिमांड ऑफ कैपिटल इक्वल टू सप्लाई ऑफ कैपिटल एंड सो ऑन एंड सो फोर्थ. माने एक इक्विलिब्रियम अटेन करना हमें जरूरी है जो हम ऐसे अटेन कर सकते हैं. Now, let us go ahead and understand what is the Walrus law stating. बहुत important है. Definitely it can come in your exam. 150%. Very, very important statement. बहुत important है. तो Walrus law बोलता क्या है? What does the Walrus law goes ahead and says? The Walrus law states that if there are n markets, and इनमें से the n-1 markets are clearing. If you go to your lecture videos of general equilibrium, I think I have also proved this in detail कि Walrus law को proof कैसे करते हैं. But for now, the statement is what is important to us. So if there are n markets, अगर n market हैं and n-1 market are clearing, so the Walrus law states that the nth market will automatically clear itself. nth market खुद से clear हो जाएगी. The nth market will automatically clear itself, and this is called as the Walrus law. माने, what does it mean? It means that suppose I take say 5 goods. Good 1, good 2, good 3, good 4 and good 5. And in 4 markets, I notice that the demand and supply are equal. Demand equal to supply. Demand equal to supply. Demand equal to supply. So if 4 markets are clearing, 4 market में demand and supply is equal, so automatically we know that in the 5th market demand will be equal to supply. इसको अलग से solve करने का जरूरत नहीं है. There is no need to solve this separately. ठीक है. Exam में sometimes they ask you the concept of finding competitive equilibrium. एग्जाम में बोलेंगे फाइंड आउट कंपेटिटिव इक्विलिब्रियम इन दिस मार्केट. कंपेटिटिव इक्विलिब्रियम का मतलब ही ये है. द मीनिंग ऑफ कंपेटिटिव इक्विलिब्रियम इज वेरी सिंपल, दैट यू हैव टू फाइंड आउट वेयर डिमांड इज इक्वल टू सप्लाई. Wherever demand will be equal to supply, that will turn out to be your competitive equilibrium. Why that will happen, वैसा क्यों होगा, we will discuss that in just a minute. ठीक है. So first thing is that Walrus law हमें clear होना बहुत जरूरी है, that if there are n markets and n-1 markets are clearing, then the nth market will automatically clear. अब हम देखते हैं एक चीज, that supposedly there are only 2 markets, good 1 and good 2. ठीक है. गुड 1 में if demand is equal to supply, तो डेफिनेटली गुड 2 में भी डिमांड विल बी इक्वल टू सप्लाई. बट अगर गुड 1 में डिमांड is more than supply. So this is called as excess demand. This is called as excess demand. So if there is excess demand in good one market, you will notice that there will be excess supply in good two market. Similarly, if there will be excess supply in good one market, you will notice that there will be excess demand in good to market. ठीक है. So when there are two goods, तो हम एक further analysis कर सकते हैं as to how the other market will react. The next concept that you have to understand, that is called as the concept of Pareto efficiency. बहुत बहुत important है exam point of view से. They may ask you find Pareto efficient bundle or the equation of contract curve. Pareto efficiency basically is all those points. माने इसका ना there are various definitions. So I think if you just open Varian, अगर सिर्फ हम Varian को खोलें, so Varian has given 4-5 definitions of what is Pareto efficiency. और हमने भी बहुत सारा we have done many definitions in our lectures. So all those points where then we cannot comment. If there are more than two markets, we do not comment on excess demand, excess supply. There is no clear aspect to it. But we can say that if there are three markets and two markets are clearing, then third market will clear. Utna we can go ahead and we can say. Okay, so Pareto efficient bundles are all those bundles where mutual benefits have been exhausted. म्यूचुअल बेनिफिट्स हैव बीन एग्जॉस्टेड, माने इस पॉइंट से हम किसी भी पॉइंट पे जाएंगे. इफ आई मूव अवे फ्रॉम दिस पॉइंट टू एनी अदर पॉइंट, देन इट इज नॉट पॉसिबल टू इंक्रीज द पे ऑफ और यूटिलिटी ऑफ बोथ. ये पॉसिबल नहीं है. It is not possible that we can increase the payoff or we can increase the utility of both the consumers. ऐसा possible नहीं है. राइट. सो म्यूचुअल बेनिफिट हैज बीन एग्जॉस्टेड. हम दोनों के बेनिफिट को फर्दर इंक्रीज नहीं कर सकते. वी कैन नॉट इंक्रीज द बेनिफिट ऑफ बोथ कंज्यूमर्स फर्दर टुगेदर. ठीक है. अनदर वे इन विच वी कैन गो अहेड एंड वी कैन टॉक अबाउट दिस is that Pareto efficient bundle is that bundle that if you move away from that bundle to any other bundle, अगर हम उससे किसी और बंडल की तरफ जाएं, to increase the utility of one, we must decrease the utility of another. अगर मुझे पेरेटो एफिशिएंट बंडल से दूसरे बंडल पे जाना है किसी की यूटिलिटी बढ़ाने के लिए, तो दूसरे की यूटिलिटी को कम करना होगा. Right? So when I move from Pareto efficient bundle to any other bundle to increase the utility of one person, I must be decreasing the utility of the other. Only then I can increase the utility of this person. तो वो भी एक Pareto efficiency का definition होगा. Right? And how do we find Pareto efficient bundle? बहुत simple है. The easiest aspect of Pareto efficiency comes when we have Cobb-Douglas यूटिलिटी फंक्शन. जब दोनों कंज्यूमर्स का यूटिलिटी फंक्शन कॉब-डॉगलस यूटिलिटी फंक्शन होगा, when we will have Cobb-Douglas utility function, then we can find Pareto efficiency through finding the tangency condition. By finding the tangency condition. And tangency condition क्या बोलता है? Well, when my ICs are tangent, इसका मतलब हो गया that the slopes must be equal. And what is the slope of indifference curve? क्या होता है slope of indifference curve? Slope of indifference curve is MRS. तो जब MRS of the two individual becomes equal to each other, उसको हम बोल देते हैं Pareto efficient bundle. That is called as Pareto efficient bundle. And when we join all Pareto efficient bundles together, माने अगर मेरे पास ये एक Edgeworth box है, ये origin of individual A है, ये B है, ये ICs of individual A हैं, 1 2 3, and ये ICs of individual B हैं, 1 2 3. When I join them together, what I get is called as the contract curve. इसको हम कॉन्ट्रैक्ट कर्व बोल देते हैं. दिस एग्जैक्टली दैट्स कॉल्ड एज द कॉन्ट्रैक्ट कर्व. ठीक है. सो इन एग्जाम दे मे आस्क यू टू गो अहेड एंड फाइंड द इक्वेशन ऑफ कॉन्ट्रैक्ट कर्व, right? So that can be one possible numerical that can be asked in your exam. So I will go ahead and I will do some numericals now pehle on this topic. So all of you try this one. Question number 1. So say you're given a utility function of individual A and utility function of individual B. And you're given that the endowment bundle of A and B find no, sorry, not bundle rather. I should say find equation of contract curve. Find equation of contract curve. Give it a try. Okay. Edgeworth box, rectangular and square. It depends on, I mean, it does not matter, huh? So if my Edgeworth box, okay, I'll do a question on it. So you do this one first and I will just give you as numerical, you'll understand. Take the same question, all of you. Okay. Hey, beta, this is why, huh? Take the same question and I'll change this to 2. Now find equation of contract curve and plot. Here also plot. Give it a try. Tell me the first one first, huh? Okay. So let's try the first one first. So for this question, beta, what will be my Pareto efficiency? It will be where MRS A equal to MRS B. What is my utility function? XA, YA 0.6, 0.4. So what will be my MRS? MUX by MUY. If I differentiate with respect to X, I'll get this. And if I differentiate with respect to Y, so I will get this. Man, I will get 3 by 2 Y by X. A लगा लेना हर जगह. Huh? This will be my MRS of A. Now let's find MRS of B. So if I differentiate with respect to X, इसको, I will get 0.4 X to the power minus 0.6, Y to the power 0.6. And if I differentiate with respect to Y, I'll get this. Right? So this will give me this is B everywhere. Sorry, just put B everywhere. I'll get this. Okay. Now I want to equate the two. So 3 by 2 YA by XA equal to 2 by 3 YB by XB. Right? So I'll get 9 by 4 YA by XA equal to YB by XB. अब एग्जाम में देयर कैन बी मेनी वेज इन विच ऑप्शन कैन बी गिवन टू यू. नंबर 1, एक तरीके का ऑप्शन ऐसा हो सकता है 9YA XB equal to 4XA YB. When I multiply this here and I take this here, I will get this. So this is correct. अगर एग्जाम में ये ऑप्शन दिया है, if you are given this in exam, this is the first one and this is correct. Right? The other way in which exam में the question will be given to you will be everything in terms of A, consumer A, या everything in terms of consumer B. So you have to be very certain in that case. कैसे कर सकते हैं in that case? So we know that the total endowment is given to us. So हमें पता है कि the XA plus XB total amount of consumption of good A of good X मान लो, this is 10. Similarly, the total amount of consumption of good Y ये भी 10 है. So YA plus YB is also 10. So if I want to convert everything in terms of A, so I can just use this simple rule that XB will be 10 minus XA and YB will be 10 minus YA. Okay? And just put that here. right? So 9ya, 10 minus xa, 4xa, 10 minus ya, and just solve this. जो भी यहाँ से आंसर है, that will be your answer. So this can also happen in exam कि आपको जो भी equation of Edgeworth box दिया हुआ है, that equation is completely in terms of individual A और completely in terms of individual B. B के terms में भी हो सकता था. So in that case, I can also rewrite this thing as 10 minus YB XB equal to 4. Instead of X, I will write 10 minus XB YB. Everything, the complete equation will be in terms of individual B. And यहाँ पे complete equation will be in terms of individual A. So any of these three, this can be given in options, this can be given in options, this can be given in options. आपको तीनों ही आने चाहिए. But very simply, what we have gone ahead and what we have done is that we have equated the MRS of the two individuals. Now, since this is a square Edgeworth box, 10, 10 and 0, 0, तो my Edgeworth box will be a square. ठीक है, इसका total dimension good X is 10 and good Y is 10. So I know that this is a square Edgeworth box. So what we have done is we have found out that the MRS has to be equal to each other, माने tangency condition, and my ICs are Cobb-Douglas. So if I just join them, whatever, you'll get a line like this. If you just join them, this will be your contract curve. अच्छा, अब ना कभी कभी एग्जाम में ऐसा भी आ जाता है that they may ask you इसी में that which of the following is Pareto efficient point, and they may give you some points. Suppose individual A का consumption 0 0, B का 10 10, second individual 4 5, B 6 5, third suppose 6 5, 4 5, and fourth say 8 to 2 8. ऐसा करके they may give you some options and ask you which of the following is a Pareto efficient point. इनमें से कौन सा वो point है जो Pareto efficient है. So you just have to plug these points in the contract curve equation that you have created. ये equation है. Whichever point satisfies that equation, जिस भी point पे the left hand side becomes equal to the right hand side, that will be your Pareto efficient point, right? जैसे if I plug this value 0 0 10 10, right? That's my first point. तो if I plug this value, मुझे क्या मिलेगा 9, right? YA is 0, XA is 0, XB is 10, YB is 10. So I will get 0 equal to 0. This is true. Left hand side and right hand side is becoming equal. माने definitely this point is my Pareto efficient point. और ये point कौन सा point है? Which point is this? Where individual A is at its origin 0, 0. माने this point. This is Pareto efficient point. ऐसे you can show that this point will also be Pareto efficient. Right. So for different points that will be given to you in exam, जो भी आपको अलग अलग point exam में दिए होंगे, आप उन points को check कर सकते हो कि कौन सा Pareto efficient point रहेगा. ठीक है, और वो check करना बहुत ही आसान है. You're just going to go ahead and you're going to just put them in the contract curve equation.